All right, Ben, what are we talking about today?
Today we're going to talk about promises. The title of the video is I Promise. There's been a debate going on for a while about, particularly in the JavaScript community, about promises and how they should work and what their interface, really what they should be. And this debate's been going on for a while, but we really haven't participated much. And we've decided that it's time that we participate. We've been working on our own, not only Promise, but our own library of async tools and helpers for a few years now.
Yeah, I think it's been since 2011, so it's almost maybe 5.
And we've learned a lot, and we've been really stingy, and we're hermits. We benefit a lot from the broader community, but we haven't really contributed much back. But today we are going to tell you how we think promises should be. And first off, not that the name is important, but for our own sanity, we're not going to be talking about promises. We call them futures.
And that's because that's what we titled them 4 years ago.
Yeah. So we're going to talk about futures. Just know that when we say future, we mean what most people are talking about when they say promise. Although we'll get to a point where I think I will argue that the name future is a better name than promise.
So just know that a lot of this that we're going to talk about today isn't something that's just off the cuff or that we haven't thought about. A lot of this has been thought about for years. We've had lots of these features for ourselves, and we've used them and actually have use cases for each of these things, and we know where they're beneficial.
Yeah, we've iterated over our features a lot, and they're in lots of applications, and we've changed them a lot. So what we're talking about today just happens to be where we are today, and it will probably be different in the future.
Yeah.
But we wanted to address some of the things that we've seen in the debate going on. So to start out with, why don't we talk about the ECMAScript 6 Promise.
So we actually, while we've done all of these, while having futures inside of our company, one of the hard things about futures is teaching them.
Yeah, it's an abstract concept, and it can be hard to wrap your brain around.
When people come, they're like, why don't I just use a callback? And they may come from a Node.js programming, and we say, well, because of callback hell. And then we explain that, but it's still hard to understand what would happen. And so what we started doing, we came up with this system that I feel is pretty explanatory. This is just, think of this as the future, and then then on that first one. Matter of fact, let's put this then in here. And then your block of code. This is like the code that you want to do after the future has been fulfilled, or resolved is what the spec would say. And then you want to chain it. Also, we're going to get into this a little bit. We call it chain, but the spec uses the word then. So you want to do that, and then you want to do this. And these can each return futures, which wait on that future to return, and then you get the value from the previous one.
One of the great things about futures is that they allow you to organize your asynchronous code in a way that makes sense.
That looks linear. It looks a lot more linear than before, when you just kind of go through this really chiasm.
So one future is great. 4 futures can be really, really helpful.
Yeah. Okay, so then we have a catch, and then let's do another then down here. So this is what the spec says we can do. The important thing is this.
So this is how you wrote it.
Yep.
We forgot our code in those.
Yeah, help me out there.
This is how you wrote it in your application, but the execution flow may not follow this path.
Yeah.
In fact, it definitely won't.
Yeah, based on what happens inside that block of code, right?
Yeah. As you know, a future can have one of two states. It can resolve, or it can error, what do they call that?
They call it reject.
Yeah, it can resolve or reject. So depending on what this future here resolves or reject, it's going to determine what the flow of the application is.
So if you look at this block of code here is actually expected to return a future with a future value for this next block of then code. So what we do is we draw this diagram that says, hey, all the successes run down this right side, and it goes to the next then.
Mm-hmm.
And so you'll notice this kind of sideways table, I guess, that it goes from then to then. Well, if this is successful, we don't go to the catch, we go clear down to the next then. The catch is simply to catch the first two, so let's draw how that happens.
If either of these rejects, then execution flow is going to go to the catch.
So it's really important to keep an eye on these angles here and how they work.
And where you go from here doesn't matter where you came from, only what happens here.
Good to note here, this doesn't really go anywhere because there's no catch after that, right?
Yeah.
So if you failed, if you're trying to resolve this, what they call is recover, this failed catch, it's off in the ether. I don't know what to say other than it's gone.
You can't throw twice, I guess.
Same thing there, right? So that is essentially what the spec gives us.
So what happens if we resolve here?
Oh, sorry. Yeah.
And we recover?
Yes, good point. It goes and recovers and then sends that resolved value. So let's say this return future, we try to recover, we go and do some other asynchronous calls, and we're like, hey, we fixed ourselves, here's the value, and then that value will be passed into this execution.
Alright, so for example, I run this code. It resolves correctly, so I'm going to follow this path.
Yep.
Probably get rid of these, because that's not actually a...
Yeah, this is the way that you write it. I guess that's a good point.
Yeah, this is just authoring. They were written this way. You're going to have a dot here.
There you go.
Anyway, this resolves, so it follows this path. This rejects, so it will follow this path, which then resolves, so we follow this path.
Yeah.
Or this rejects, it's going to follow down here. If this rejects, nothing,
Right.
That's the...
So this is the spec.
Yep, that's the standard ECMAScript Promise.
Yeah.
So, part of the debate going on, we should talk about.
Let me see where that is, so we can maybe. I'd like to see them side by side, so you can see the.
Is there room?
Yeah, there's room right there.
I don't want to title that promise.
Oh, so we call this.
True.
That's a good
This
point.
is not a future.
Oh, by the way, we have two voices from heaven today. We have Anthony here and Rhett, so they're here to give us feedback when we're not making any sense.
Okay, now let's talk about hours.
Okay, so we have. Yeah, go ahead.
In large part, it is similar. Go ahead.
It is.
You can draw.
So we have a similar thing here. So we're going to draw the same amount of boxes. Well, a few more actually. But I'd like to keep it as close as to the other one as possible. I think we've got two more. So then, I don't know how far down we can go. I'm going to go see if we got that. It's really important to see these different, we have to have this many thens and catches in here with this other stuff that we decided to add, to augment. So this is what we've done. So we have a then here, catch, the same thing. And then I think what we did is we did this then as well. And we have we call it catch, canceled. And then we have another one called finally. All of these that we're going to talk about are very useful, at least we think so.
So one of the let's fill out the normal execution
Yeah,
path
let's do that.
real
So
quick.
you want to do the success,
I'll do this
I'll do the error.
So this is good. We're gonna go here.
So these are just big question marks. Oh, that doesn't work. Okay. And that doesn't even matter
Recover
either.
from a cancel.
No, you cannot.
Okay.
That is the end of the game. Okay. So I think you did. Yeah, there you go. That's right. Yep. And yep. Perfect. Okay. So there's two things you'll probably notice up here. The first thing is we have this finally function, which whether it's rejected or resolved, we can do some code. There's been times where we don't care. We just care that it was done. This can happen with,
So does this fall down into there?
oh yes, sorry, no, that's an error. So no, it does not. So if this error is out, oh, it does go down there, but it doesn't go that way. It would go, how would you draw that? We'll draw that with another color. We needed one more color, but okay, we'll explain that with black, I guess.
Okay.
So let's go through this scenario here, where you can use finally and catch. Well, finally gets called regardless. Like it is going to be called no matter what. So we probably shouldn't even. Let's not even do this. Let's draw it with black, and just say no matter what, no matter if this fails, it's going to get called. If this fails, it's going to get called. That's not even matter. I'm not going to go that way. Same thing here, right? So everything funnels to finally, and that's been useful for us. We've seen a need for it, so we added it.
The future is said to be, there's a word for it, done. It's a better word than done. But whether it's resolved,
Yeah.
rejected, whether it's resolved, there's an error, or it was canceled, it's done.
Yeah.
And you will call the finally.
So we actually, when I started realizing what futures potentials were, I realized it was a lot like a try-catch thing. You basically say, hey, I want to try to do this, and hey, if it fails, I want to catch it, and then if I kind of want to do some cleanup on, regardless if it was successful or if it erred out. So you'll see a similarity there, and that's why we actually added another. We'll talk about this later, but we actually say when to execute and when not to execute, and so you have a try, which is this stuff, and then a catch, and then a finally. So this actually mocks a little bit the try-catch statement, and it should, in my opinion.
Yeah, okay, now let's talk about the first point of debate going on right now, and that is, should a promise be cancelable?
Yes.
The ECMAScript promise is not cancelable.
And there are good arguments on the other side. For example, if you're going to say you're going to promise me something, then give it to me, right?
Yeah, I heard a guy say, if I make you a promise and it doesn't resolve or reject, that's not a promise, that's a dirty lie.
That's quite true, right?
The other bit of heartburn people have with that is that cancelability is handed out along with the promise wherever it goes.
Correct.
So you're ceding control over the execution of your program to who knows what.
Where it's been passed to.
Yeah.
There are good arguments against that, but from what I found, a good example of why I need to know. I think people don't like it because they want to be able to react to it. The current promise didn't have a way to react to the change of. They just had to resolve and reject, right? So when we want to catch it, this is what we're going to do. When it's successful, this is what we want to do. Well, when we cancel, we don't do anything.
Right.
Now they have no way to respond to it. And that was, I think, the problem, is there wasn't this function here. And so if any of these, if you look at this, they actually, if any of them are canceled, so if let's say any of these futures in this whole thing go into a canceled state, they all go in to this cancel right there. So the whole thing gets canceled. So like if you cancel it here, none of this gets called, but this. And it goes all the way down. There's no recovering. There's no way to recover from a cancel. It's like the stack has been blown.
Somebody has decided that the work doesn't
matter
anymore. We're done working.
Yeah.
That whole chain is
gone.
But we have the opportunity to react.
Yes.
If we really care a lot, we can try and retry something that didn't happen before. We can clean up resources. We can do smart things.
And we'll go through a UI example with catch cancel that's really, really superb with this flashcard example that we might talk about a little bit later.
Yeah.
But this is really crucial for that. There's been one time I tried to put the cancellation feature inside the error, but it's really not an error. So then I was trying to say, well, cancellations are kind of like errors, but they aren't errors. And then I said, you know what, bag it. They're different things. There's errors, and then there's I'm canceled it. There's don't run anymore. You can't recover from this. We're done.
Yeah. So somebody might argue, this is kind of pretty because we have two states for any part of this chain. You can either resolve or reject.
Yeah.
and that's clean. We've gone and added this canceled state. What's to stop us from adding 14 more? Why doesn't this just proliferate into, well, I might want to suggest, or wait, or tell a joke? I don't know. How come 3 is the right?
The reason why I think it's the right thing is because when we first started, we didn't have cancel. And we started doing these AJAX calls. And in these AJAX calls, we were hitting an OData service and getting results back from an array. And we had this infinite collection that's it's going through this, making these calls, paging basically. And there's a time where they scroll so fast that what we just called for is we're still retrieving it, and it's clear up here out of the screen. We wanted to say, just abort the XHR, abort the thing. And so we have a way built into features where you can resolve and reject, and if canceled. So you actually register yourself to the, if it's going to get canceled, then what do you do? And in that case, we did XHR abort.
Yeah.
It was magnificent because now all those calls that went out, you can throttle, they throttle your calls out to a server. So if you've got more than 6, you can't get any more out.
Yeah. So if you're flipping through a list view, you've opened 70 requests for information. If you can't cancel those, then you're going to have to wait for the top 60.
Right. And that actually happens with dragging the scroll bar.
It becomes a particular problem if you're on mobile. Now the fetch API, which I think is a great idea, and it's way better than XHR and all that goofy stuff from 1990 whatever. It's way better, but fetch presents a standard promise API, and you cannot cancel a fetch.
So now I'm not going to use it because I can't cancel it.
We have performance constraints that demand that we are going to use XHR because it's cancelable.
You're right.
And that is why I think maybe one of the answers to this whole debate is that we don't call it a promise. Because I can ask you for information and be waiting for that, and you'll either give me the information or tell me that you can't. But one thing that might also happen is I tell you, never mind.
Well, that happens all the time with like hotel reservations, right?
Yeah.
Or even plane tickets. Hey, I want to do this, and let me know. But you as a customer can decide, never mind. I guess if you buy insurance, travel insurance.
Yeah.
But the point is, you can still opt out.
I'm just not interested in that.
Yeah.
So if we're hung up on the word promise, let's
get rid of it.
Not call it a promise. Or
have both.
Maybe we need both. Maybe these are 2 different objects. Maybe there are cases where you don't want to cede control over the execution chain to any Joe on the street. So maybe we do need a non-cancelable promise and a cancelable future.
So my only problem with that is they better be composable together, because if they're not, then you're going to have, you can't chain them the same way. You can't chain a future, right, with a promise. And that becomes very bad.
I can see this also turning into a pretty bad developer experience when you don't know what you're getting back. I mean, this is JavaScript. We don't get a lot of help from the tools.
Right.
Am I getting a promise or a future? Is it cancelable or not?
Right.
That could be pretty rotten.
Yep.
So, anyway, that's our case for cancelability.
Another thing that we, just to second that, with XHR, we actually did it with our animation framework as well. There's sometimes where we wanted somebody else to decide, hey, I want to cancel this. And it's not necessarily directly tied to the animation. It could have been like the UI is animating something over, but the user clicked another button really quick, and we just want to stop the animation. Well, we didn't want the other UI to know about the animation. We just wanted to hand them the future, and we put it in this chain, and when they say cancel, then the animation knows what to do. And that was very, very helpful as well.
So I guess the moral of the story is we don't really care what it's called. We just know that we need an asynchronous helper object that is cancelable.
I think I'm convinced that you need a way to cancel features. I'm not convinced, maybe you can explain a little more, why that wouldn't just be another flavor of an error. Like you said, you tried to implement it that way and decided, no, we need a separate thing called catch canceled. Why can't that just be a catch where you specify in the error that's passed through that it was a cancellation error?
So what I found there is that the first thing is with cancellations, you really do want the whole stack to stop.
They're non-recoverable.
Like, you cannot recover from this.
Where
catches are recoverable, and for good reasons, they're recoverable. The other thing is in your catches get really ugly. Is this really canceled, so now you have this if statement inside of your catch,
Sure.
forking your execution. And so those are the two reasons that I saw when messing around with the idea of putting it as an error. And I didn't like it, because now I'm like, well, you know, you can send, what we did is you can say, hey, we're going to reject it, and here's the error object, and the message is, the message is canceled. Well, someone else could mock that. And now, instead of it being part of the state machine inside of the future, someone could just say, accidentally name the message canceled, and now responding to it as if it's canceled, but it should be going off the execution of an error. And so that kind of, I guess you could do maybe a type-specific cancellation error, but even then you're going to be doing an if statement. Are you an instance of a cancellation error? And that's just, again, a bad idea, because now you're trying to recover from something that somebody said, stop the whole thing. You don't want them to be able to recover.
Makes sense.
Yeah.
Yeah, that was convincing.
Yeah. Anthony's gonna chew on that.
Yeah, we'll chew on that. I hope
Okay,
that we have a better answer.
let's move on to the second point of debate. Do we need these diagrams?
I don't think so. I hope they
anymore?
can.
We might
remember
draw
those.
one more at the next step. I don't know.
That's true. But we could. They're pretty
Well,
simple.
yeah,
Then.
we
We needed 2 erasers. Is what we needed.
All right, the second thing that's being hotly
Okay, let me
debated.
erase while you talk.
Okay. I guess it's not been so hotly debated lately, is I guess Chrome implemented a thing called a deferred promise, which was like a promise, only the resolver was exposed and could be passed around to other objects.
Yeah.
And for some people it seemed like a good idea on the surface, and for others it was a really, really bad idea, because that part of the idea of a promise is that resolver is encapsulated and controlled, and you know.
It's functional programming, a monad,
Yeah,
control.
it's isolated and it's uncontrolled. And when you're just going to hand the resolver out to who knows who, anything could happen, and your program could break because of nothing that you yourself did.
Correct.
And we agree with that. The promise should not expose the resolver. However, we have found a couple of cases now,
Yeah.
where we did want this asynchronous helper object to be externally resolvable, which I guess was the idea with the deferred promise. But I think deferred promise is a really bad name.
We're on that name thing again, aren't we?
There are 3 hard things in computer science, not 2 hard things.
Hey, you gave it away.
Dang, I messed it up. That's a great joke. So we have been using for a while something called a fulfillment,
Yeah.
which we're not going to explain because just like an hour ago we decided it was a bad idea. A fulfillment is a promise with an exposed
It's
resolver.
just like a deferred promise.
Yeah.
Essentially.
So your fulfillment had this resolve function, and you could put a value in here, and then anyone who was holding on to the fulfillment could react to that.
Yeah.
And then, we got a great use case for that, but after thinking about it a little, we're going to retire the fulfillment. We just unilaterally decided this for the whole team.
I wish we recorded that conversation because it was quite good.
And we are going to replace it with what's called a resolver. So let's get rid of the old fulfillment stuff and explain what a resolver is.
So the resolver would, this is how the interface would work. Like we said, we haven't written this yet. But the idea is this, is that you have party, let's say we have party A, party B.
I guess at this point we're past the debate that's been going on, at least as far as I'm aware of it. We're going to go into some features of the base future that we happen to really like, and we'd like to know what you think. So the ES6 Promise interface is really simple. There's a then and a catch on an instance of a promise. Our interface has a little more.
So we have a try. So this is what tells it to go. We have a then, which isn't exactly like that. We have a chain, which is like that then.
Yeah, our chain is
That then. Then we have a catch. And then we have a catch canceled. And finally, what else have we got?
I think that's it.
I think that's it. Oh yeah, and then we have the usual all on the,
Oh,
on
yeah.
the static
These
methods.
Instance methods, yeah,
We have all that stuff too.
we call it different, like from error.
We say from result and from error, and they have resolve and reject
Yeah.
on theirs.
Okay, so holy cow, this is a lot of interface. Why in the world would we need so much interface? Like we said, our chain is synonymous to the promises then. The catch matches up too. We'll talk about try in a minute.
Mm-hmm.
But let's distinguish between then and chain.
Chain. So the reason why then we treated then differently is when we first did futures, we didn't have this chaining type capability. And what it was like is like if you're interested in this future, you'd have everybody that's interested kind of like hanging out here, like, hey, we're all interested in this value, right? They're all hanging on to this future, waiting for that value to come back, and they're all right off of this future. Well, when chaining, when we started implementing the way that the spec did, we realized that that's actually creating an extra future in the middle to then your next chain. So like if you're to say, hey, I want to chain this, it's actually waiting for a future that this future returns back a value. We put a future in the middle, and then we're able to do our code, and we're going to take that value from this future. I hope that made some sense. But every time you do a chain, you have an additional future in the middle. And that's the point of this. The point of that is, remember how we talked about that, if you remember those boxes, let's go back to those boxes. This kind of looks like the boxes we had before. What this really did is we had the errors coming out the side of the boxes, right? That's not where it's happening. It's actually happening in this middle future. And this middle future decides which track it goes down. So if this future that's sent back from the then of this, so this is our code, and we return a future, this is that future right there. And so there's this future in the middle. We actually fulfill it, so we take this future, stick it inside of this one, so we can say, hey, did you error out or did you not error out? If you errored out, then we need to go this way. If you didn't error out, then you're going to go that way. So it is heavier. If you use chain, you're having an additional future in every time you call that.
So in other words, our then returns
The same instance as that, the whole thing.
Yeah, this returns this future.
Not the middle one.
So when I guess to write this a different way, if I say f dot then do work dot then do work dot then.
That is like, here's the future, and you're just piling on these bins.
Yep.
Bin.
When this future resolves, this and this and this, they're all going to get executed as near as JavaScript will allow simultaneously.
They will be synchronous in that regard.
Yep.
But they're not responding to it, the value returned from this one. So the way that the chaining or the thinning happens here is whatever this returns, if it's a future or a value, is now the value for that function. So
Yeah.
and so this
chain.
that in our chain.
I'm going to erase the promise here because now we're just confusing. These are all our
Yes.
futures.
Yes.
And yeah, then returns the original future.
Yes, the original.
Chain returns a brand new one.
A brand new one with the value that was returned from the first block of code executed.
Yeah, f dot chain.
Let's give an example of that so we don't. We can write that. I can write that real quick.
This value is going to go to there. Is going to go to there.
Let's do the fat arrow. So here's your value, and then let's do a dot. Then again to show that this is going to be the same as that one above. Whoops.
There are cases where this is useful. We've done it before. We thought about abandoning this interface and just adopting the chain interface from the standard promises, but decided we
It's
really
useful.
like this in certain places.
So all of these actually, in this regard, so I guess we need to do one more chain here. And this is this value 2 is what we should call it. So wherever I have v, that's all going to be the same return value. So off this first future, this value is going to be the same value as that. Triple equals, it's the same
Yeah.
thing.
It is a reference to the same object, and
Yes.
it is the resolved value of this
Of that
original
one,
future.
yeah. So this result value of that future is going to go here, is also going to go here. This, on the other hand, is going to come from the return value of here. So if I were to say return 1, then that v2 would equal 1. But you have the option inside of these to return a value or
A future.
a new future. So what that does allows you to go do some more asynchronous work, and then whatever the return value of this future is goes here.
Okay, that's chain and then, and again, we can go into more depth on that if anyone would like us to. Let's talk about try.
Try is really important.
This seems to us to be a pretty glaring omission in the spec. We were a little surprised to find that standard promises don't defer work.
This is huge for us. We do a lot of composing. So remember how we did that chaining of things? We'll actually gather, what we'll do is we'll say, okay, most things, their responsibility with futures are to just hook all what you hook up all that you want to do, just in a sequence.
Mm-hmm.
Just build up what you want to do. And when you build it up, the person that's calling you to build that, we'll say build async, right? That's what we call it, build async.
There's a bunch of code in here, you know.
Yeah, these are all features, so future, and these are chains, what we call chain. So we're organizing the units of work. Let's say there's a catch in here too. And then we're just going to return f. And it's up to the person calling this function to do a try.
So when we do this, none of this code is executed.
It's not, none of it
It
is.
is absolutely inert.
It's just composed.
You could have futures that never even tried to resolve.
And it's really beautiful. And we've done this a lot. And it does wonders because you can separate your composition from going to get it. So a good example of this is we want to compose an AJAX call in a little while. Let's just say, hey, get this resource. And based on a condition, an if statement, we're going to go then it or not.
Mm-hmm.
Without it being deferred, it's going to go get it no matter what, and it's going to be back before we even have a choice to say we wanted it. So that's just execution that's not needed.
Right. I could say, I could have at the very front of my application this preferences object that has to do some asynchronous work to go to the server and pull back a bunch of preferences.
Yeah.
I want that to be available. I want that object to be available to everywhere in my application or a bunch of controllers in my app. But I don't necessarily want to do that right now.
You guys are using get as an example. Imagine a post, right? I don't
Yeah.
necessarily even know what I want to post yet. I might not have the data yet, but I want to
Yeah.
describe what it is. That's even
Yeah.
more.
Yeah, if you don't know yet, or the work you're doing is particularly difficult, if nobody in the application ever
Wants it.
used the preferences, why should I go out and get it?
That's exactly right. But we want to define what it does to go do it. And there's a lot of chaining and mapping of values down to the very end.
Now, it might be that I want to front load those permissions at a certain point. Like I'm getting close in the application where I want those permissions to be loaded.
Uh-huh.
I still don't think that's an argument to load it at the front of the application, but we can always just say f dot
Try.
try. Try executes a future when you are not interested in the value. Like you can't put anything in here.
Yeah, that's basically saying, hey, we just want to go and run the code. Just run whatever you've chained
Execute the
together.
future.
Mm-hmm.
Go.
What then does for us, we didn't talk about this earlier, I'm glad we're doing this, but then is like doing, so then is synonymous with a then, a try chain. So if you think of it this way, it's not synonymous, but it's close to the same thing. So then actually goes and says, hey, someone is interested, go get the value right now. And then respond with your callback. And so we've seen that this deferred execution is very beneficial. You can compose without executing, and it's very efficient.
Yeah,
I can't say anything else other than that. We use it a lot.
we really like it.
We rarely see, to be honest, when you look through our code, 90% of our code or 98% of our code has chain. We just have always said chain everything together. And then the person that's interested in the value, they're responsible for the then or the try. And there's very few of those because there's lots of other things just being composed and then things calling it and then wanting to know the value.
Yeah.
So we actually have it, if we see a lot of thens and tries, we scream. Because it just means it's executing when it should.
Right. Yeah. So that's basically the base async library. We will have a link to the code set up here when the video is published. The video is published.
Right,
now,
that's right. It is
isn't
published. Wow, that's amazing.
Talk about a future.
Future.
There's a link to the code. We have a GitHub repo. It's in the description. And
We'll have some demos. For
yeah,
them to
we'll
dig
have
around
some
the features.
demos. We really want to be part of this conversation now. We're tired of being silent observers
Hermits.
and hermits. Yeah, we promise not to be hermits anymore. But we really appreciate you watching, and we want to know what you think.
Thanks.